Okay, in this video, I'm going to talk a little bit about how we can use the limit laws that we thought were kind of silly in our last unit to really help us simplify these problems that we're doing right now. So if we look at f of x equals x squared and g of x equals 3x squared, we know from all of our work in class this week and last week that the derivative of x squared is 2x and that the derivative of 3x squared is 6x. I changed this one to be g of x so you can really see the connection, right? F of x has its derivative f prime, g of x has its derivative g prime. So let's look at this limit for a little while. So for the first one, we have the limit as h approaches 0 of x plus h squared minus x squared over h. And for this one, we have the limit as h approaches 0 of 3x plus h squared minus 3x squared over h. Now, maybe you remember, maybe you don't, these limit laws that we learned in the last unit. And this one right here, the constant multiple law, says that if you're multiplying by something inside here, right, you could just take the limit and then you can multiply by it afterwards. And I remember one of the groups testing this out and presenting it to us. So what we could do in this second one over here is, because these both have a factor of 3, we could factor out the 3. And we could say that this is really 3 times this limit right here. No 3 there anymore because we factored it out. Okay, and then just like we saw on that other slide, we can bring this 3 out here, and I'm just going to erase it and move it so that I don't run out of space. So I can multiply 3 by this limit. Well, now this limit right here is this limit right here. And since we know that this is 2x, we know that this whole thing right here is 2x multiplied by 3, which means that it is 6x. So that's using the constant multiple law. When you just have the same function and we just multiply it by a constant in the limit, we just are multiplying this original limit by a constant. So we can just do this limit, which we already knew the answer to, and then multiply.